Hi everybody, hope you had a great weekend. We're going to jump right in here. We're not doing any real new concepts today, we're just going to apply the Pythagorean theorem to a couple different problems. We're going to do just two practice problems together, and then if you haven't already either printed or at least found the 9.1 through 9.4 review problems worksheet, you're going to work on that after these couple of practice problems, and then I'll go over the answers with you with that when you're done. Okay, so example 1, we're finding the length of the longest possible diagonal of a box. Okay, so if you can tell from this diagram here, where that diagonal is sort of floating in the middle of the box from this bottom corner up to the opposite top corner. Okay, so D would be floating in the middle of that box diagonally. Now D itself is part of, let's see if I can trace it here, this right triangle, where you have sides D, X, and 18. But obviously we can't find that yet because we don't know X. And just to note, this is not necessarily a special right triangle. We don't know anything about the angle measure, so we're not going to do anything with a 30, 60, 90, or 45, 45, 90 in this one. And what we do need to find is X. Now X is part of this triangle lying on the bottom of the box. That one we can find right away. So we're actually going to find X first. It's just a Pythagorean theorem problem. So we start here, 6 squared plus 24 squared equals X squared. Okay, and that we know how to do. We're going to square both of these numbers. That's 36 plus 576, or 612 is equal to X squared. Now I'm going to put a little note here in parentheses. That's about 24.7. I don't actually care about that length, and I'm actually not going to even use that number. I'll show you why in the second step. So once we know X, we can find D. This is just a second Pythagorean theorem problem. So now we'll find D. And this looks like X squared plus 18 squared equals D squared. Now I could take this 24.7, plug it in, square it. But if you retype that, you're going to get some rounding error. But if you notice, if I kind of back up a step here, X squared is just 612. So if I square 24.7, I'll get pretty close to 612, but you're going to see some rounding error in there. So why not just back up a step and use what X squared is already? Now 18, I obviously have to square still, so that's 324. And then once we add those, we get 936. Square root of that is about 30.6. Now that one I am going to round. We do want an actual length for our answer. Okay, about 30.6 inches for that one. Okay, so just a two-step Pythagorean theorem problem. Find the diagonal line in the bottom of the box first, because you have two of those sides, two of the three of those sides of that triangle, and then use that information to find our longest diagonal in the box. One more I'm going to do with you. I'm going to take a second and pause this if you need to copy that down. 25-foot ladder is placed against a building. The bottom of the ladder is 7 feet from the building. If the top of the ladder slips down 4 feet, how many feet will the bottom slide out? And you can see the note right away here. It is not 4 feet. It's tempting to just put 4 as our answer. I'm going to draw what we're working with in the first triangle here. So we've got a 25-foot ladder, so that would be leaning here. It's leaning against the building. It's 7 feet from the bottom. You can assume that the building and the ground are perpendicular to each other. Okay, so what we're trying to figure out is how many feet the ladder is going to slide down once we kind of shift this. So I'm going to call that Y for right now. And why don't we just do this? We have enough information, let's find Y. If we can just kind of pause and find this right now, it's going to make the next scenario a little bit easier to work with. So this example, that's just a Pythagorean theorem. 7 squared plus Y squared equals 25 squared. If you know your Pythagorean theorem triples, or your Pythagorean triples well, y is exactly 24. If you don't, just go ahead and calculate that one on your own. Okay, so this is 24. Now, all we're going to do is just adjust our triangle. It says that it's going to slide down 4 feet. So instead of being 24 feet up the building, which is a little bit shorter now, it's only 20 feet up the building. The ladder is still 25 feet long. That's sort of the key to this problem. You need to realize that that does not change. What does change is this length. As the ladder slides down, it's also going to slide out. So notice compared to this side, this is going to get a little bit longer. We just have to figure out how much longer. So we've got another Pythagorean theorem problem here. 20 squared plus x squared equals 25 squared. This is actually another variation of a Pythagorean triple. Go ahead and solve that step by step if you need to, but we get x equals 15. For this one, this is a 3, 4, 5, but 5 times bigger. So instead of 3, 4, 5, we've got 15, 20, 25. Now, just to answer the question, how many feet will the bottom slide out? We just need the difference between those two lengths. So it went from, oops, I'm writing a 2 there. 7 feet initially to 15 feet. The difference of that is 8 feet. Okay, and just a note, because you're going to see another problem like this in a minute, let's please not assume that it just doubles either. That is not the case each time. But in this particular example, the length does go out 8 feet. Okay, so right now, you should pause the video, complete these on your own, come back and check the answer key. Okay, go ahead and check your answers for the first 3 there. I'm just going to make some notes. I have all of my work there, but let me make a couple notes. In number 1, they're giving you the area. Please don't forget the 1/2. Okay, so we end up finding the height. You see the sides I have traced here? Those are actually the base and the height because they're perpendicular to each other. So that height we get is 13. Then we can use that to find x in just a Pythagorean theorem problem. Number 2, you need to find this vertical piece first. Of course, you could have a decimal there. Your answer might just be slightly different from mine at the end if you rounded this one right away. So I can cover that. So that was the square root of 132. If you don't have exactly 23.9, or pretty close, maybe you rounded this number, and that's okay. Number 3, there's 2 ways to do this one. If you notice, we've got an equilateral triangle, also known as an equiangular triangle. This is how we started the 30, 60, 90s. So either way, you're going to have to find this height. But if you notice it's a 30, 60, 90, you can pretty quickly find that height right there. If you did not notice it was a 30, 60, 90, that's okay. You'll get a height of, let's see what that is, about 6.06, just using the Pythagorean theorem. That's fine. We'll get a very similar answer at the end. Make sure, again, you didn't forget 1/2 in the area formula. Okay, numbers 4 and 5, remember, you're just testing, do those numbers work in the Pythagorean theorem? So is this a true equal sign? And in both cases, it does work out. 6, 7, 8, there's a couple more special right triangle review problems. Check those out, especially 7 and 8. I think 30, 60, 90s are a little bit harder. You can see what I wrote here. Those were just those little chants I was doing to myself. Remember to try to remember those relationships. So 1, 1, square root of 2 for 45, 45, 90 over here. 1, 1, square root of 2. And then over here, 1, 2, square root of 3. But you need to remember that 2 is bigger than the square root of 3. 2 is the one that would go the hypotenuse. Square root of 3 ends up on the longer leg. This triangle is 3 times bigger than this base triangle, 1, 2, square root of 3. Okay, diagonal in a box. You can follow my notes there. We have to find x first with the triangle lying on the bottom. It's about 19.3. Remember, we don't actually care about that number because right away in the next step, you're going to use x squared. So working with this triangle now that's floating in the middle of the box, we're going to work with x squared. So that I just plugged 373 right into that. Okay, we end up getting 22.2 for that one. Go ahead and work through your steps there. And if your numbers are slightly different than mine, it may just be a rounding issue, and that's okay. And then number 10 starts out with a 20-foot ladder reaching 18 feet high. How far does it move if the ladder is lowered by 2 feet? Okay, so slightly different setup than the last one. We get, with our just original Pythagorean theorem problem, 8.7 feet. And I would just start right away. Just think about that first triangle, figure out the distance the base is from the building, and then just redraw your second triangle, keeping in mind, this is important here, that this is still 20. That ladder does not change its length. Don't forget to actually answer the question at the end. It's not 12, it's the difference between 12 and 8.7, or 3.3. Okay, that's it. Have a great day, everybody.